Hello students, in today's lecture I'll be continuing with the instruction set of 8085 microprocessor. In my previous lectures I completed the data transfer group instructions. In this lecture I'll be starting the arithmetic group instruction set of 8085 microprocessor. So to start with, in the arithmetic group, the first instruction that I'll take is ADDR. So what ADDR instruction does, it adds the content of the register, whatever register is mentioned, it adds the content of the register with the content of the accumulator. That is, if for example, if the instruction is written in the form ADDB, then what it will do, suppose at the time of the execution of this instruction the accumulator content is 40H and the content of register B is 20H. So after execution of this instruction ADDB, what it will do, it will add the content of accumulator with that of content of B, that is A plus B, that is 40 plus 20 is equal to 60H, and the result will get stored in the accumulator. Now flags affected, since we are discussing the arithmetic group instruction set, means every instruction of this group will involve arithmetic operations. So all flags, that is sign flag, parity flag, carry flag, all flags of 8085 microprocessor will get affected with respect to this instructions. Now number of bytes, so as you can see ADDR, for example I've taken ADDB, you can write any register in place of R is representing the registers of 8085 microprocessor. You can write B, C, D, E, H, L, any register you can write. So for example here I've taken ADDB. So how many bytes of instruction are there? So as I've already told you that every instruction of 8085 microprocessor is of 1 byte, is minimum of 1 byte, because 1 byte representing the opcode of that instruction. Now if there is any hexadecimal number mentioned along with the instruction, then the number of bytes of the instruction will change accordingly. Now as you can see that there is no hexadecimal number mentioned in the instruction, so the number of bytes of this type of instruction will be 1, that is for opcode. Now machine cycles, how many machine cycles are used for the execution of this instruction? Suppose you're writing ADDB, suppose you're writing this instruction, you have given this instruction to the microprocessor. So this instruction will get stored in the memory. How it will get stored? Only the opcode will get stored, as there is no hexadecimal number, so no more memory locations will be used for storing the instruction. That is, only one memory location will be used for storing the opcode of this instruction. Now at the time of the execution of this instruction, what microprocessor will do, it will use one machine cycle for fetching the opcode, one machine cycle for opcode fetch. Now after fetching the opcode and decoding it, microprocessor will get to know that it has to add the contents of the accumulator and register B. Both the accumulator and the register B, or any register whichever is mentioned in this instruction, those registers are present within the microprocessor, so microprocessor does not have to perform any extra machine cycles for the execution of this instruction. So in only one machine cycle the whole instruction will get executed. So it is opcode fetch machine cycle. Then number of T states, how many T states? As opcode fetch machine cycle has 4 T states, so only 4 T states will be used for execution of this instruction. Now next the addressing mode. Now as you can see ADDR, or as I've given the example ADDB, this instruction here the content, that is operand, is the content of registers. Here the operand is the content of registers. B is also a register, and A that is accumulator is also a register. So the addressing mode will be register addressing mode. Now coming to the next instruction ADDM. What does ADDM instruction do? Again, it is a addition instruction. It will add. What does M represents? M is the memory location whose address is represented by HL pair. Suppose at the time of execution of the instruction, let the content of H is 20H, let the content of L is 60H, and then we have the memory location. We have the memory which is associated with 8085 microprocessor, and suppose the memory location whose address is 2060H, that memory location has the content 30H, and let us suppose the content of accumulator is 40H. So after execution of the instruction ADDM, what does ADDM will do? ADDM, what does ADDM will do? It will add the content of accumulator with the content of memory location whose address is represented by HL pair. Means after the execution of this instruction, what will happen? Microprocessors will see what is the content of H and L. So the content of H is 20 and the content of L is 60. So all total what it is? 2060H. So that address, so that memory location whose address is 2060H, the content of that address, this is the memory location M, and the content of the address will get added to the accumulator and the result will get stored in the accumulator. That is, after execution of this instruction, what will be the answer? 40 plus 30H, what is 70H, which will get stored in the accumulator. Now flags affected, again it is a arithmetic operation. So flags, all flags will get affected. Number of bytes, again since the instruction is ADDM and no hexadecimal number is mentioned along with this instruction, so the number of bytes of this instruction will be 1 byte only, which is the opcode of the instruction. And then number of machine cycles needed for the execution of this instruction. So suppose let's take the example ADDM. This is the instruction. As I've told you, let us suppose the content of H is 20H and the content of L is 60H and the content of 2060 is 30H. Now if you are giving the instruction ADDM to the microprocessor, it will get stored in the memory. How it will get stored? Only the opcode will get stored in a memory location. So to execute this instruction, what microprocessor will do? It will use one machine cycle for fetching the opcode. Once the opcode gets fetched and decoded, microprocessor will get to know it has to add the content of a memory location whose address is pointed by HL pair to the content of accumulator. Now microprocessor is having the address because the address is pointed by HL pair. So the address 2060 is already present in the microprocessor. So the next machine cycle will be used by microprocessor to read the content of this HL pair, that is to read the content of the address pointed by HL pair. So to read this content, microprocessor will use another machine cycle. So second machine cycle will be used for memory read. So all total 2 machine cycles are being used by the microprocessor. One is opcode fetch and the second is memory read. And after fetching this or after reading this data, microprocessor will add the content of this content with the accumulator and the result will get stored in the accumulator. So all total 2 machine cycles are needed for complete execution of this instruction. T states, as opcode fetch is having 4 T states and memory read is having 3 T states. So all total T states for this instruction is 4 plus 3, that is equal to 7 T states. And addressing mode, and now as you can see, what is the instruction ADDM. So the operand here, the operand is accumulator content and the operand is the content of memory location, or you can say the operand's address is indirectly specified by HL pair. So this type of instruction will have registered indirect addressing mode. Now moving on to the next instruction, ADI 8-bit data. So what this instruction will do, suppose the instruction is ADI 26H. So what this instruction will do, it will immediately add the content 26H with the content of the accumulator. So let us suppose how this instruction will get stored. This is the memory that is associated with the 8085 microprocessor. So when you're giving this instruction to the microprocessor, how it will get stored in the memory? First the opcode will get stored, first the opcode of this instruction will get stored in the memory, and second, if there is any hexadecimal number, it will occupy the next memory location. So there is a hexadecimal number, there is a 8-bit data, so it will get stored in the next memory location. So all total 2 memory locations are being occupied by this instruction, so the number of bytes are 2. Or you can say, since there apart from the opcode of this instruction, 1 byte hexadecimal number is also mentioned along with this instruction, so all total bytes the instruction has is 2. Now one for opcode and another for the data whichever is mentioned. Here I have written 26, any data, any 8-bit data you can write. Now what will happen at the time of execution of this instruction, microprocessor will use 1 machine cycle for fetching the opcode. So first machine cycle for fetching the opcode and decoding it. Once microprocessor decodes the data, it will decodes the opcode, it will get to know that it has to add certain data which is present in the memory. It has to add that data with the content of the accumulator. So second machine cycle will be used for memory read, that is reading the 8-bit data present in the microprocessor and then adding it with the accumulator, and the result will get stored in the accumulator. So so all total machine cycles are 2 machine cycles, opcode fetch and memory read. Now T states. Since the opcode fetch machine cycle has 4 T states and memory read machine cycle has 3 T states, so all total T states that the instruction needs is 7. 4 plus 3, 7 T states. So here I have written also 7 T states. And addressing mode of this instruction, since this instruction has here the operand is directly mentioned in the instruction, so the addressing mode of this instruction is immediate addressing mode. So again I am repeating what this instruction will do, it will add the content of the accumulator with the data mentioned in the instruction, and the result will get stored in the accumulator. Now next instruction is ADCR. So the next instruction is ADCR, that is this instruction is addition with carry. So initially whatever addition instructions I have told you, they were just addition. There was no carry term, or we didn't talk about any carry. That instructions does not involve any carry term. So the next instruction ADCR, it will add carry also. So what this instruction will do, it will add the content of accumulator with the content of register, whatever register. Suppose if I have written ADCH, suppose I have written ADCH. So what this instruction will do, it will add the content of accumulator with the content of register, here H is mentioned, and it will also add the content of carry flag. So and the result will get stored in the accumulator. Suppose at the time of execution of this instruction, the accumulator content is 20H and the content of H register is 30H, and the content of carry flag, and the carry flag is also in set position. So after execution of this instruction, what will happen? 20 plus 30 plus 1, 51H will get stored in the accumulator. Now flags affected, obviously since it involves arithmetic operation, all flags will get affected. since it involves arithmetic operation, all flags will get affected. And the number of bytes, again ADCR, no hexadecimal number is mentioned along with this instruction. No hexadecimal number is mentioned along with this instruction, so the number of bytes will be 1 byte only, and that is for opcode fetch. Machine cycles, how many machine cycles? Only one machine cycle will be used for the execution of this instruction, that is for fetching the opcode. So after fetching the opcode and decoding it, microprocessor will get to know it has to add the content of accumulator, then it has to add the content of register and carry flag, and all these three things are present inside the microprocessor, and the microprocessor does not need any extra machine cycles. So in one machine cycle only the whole instruction will get executed, that is opcode fetch machine cycle. Number of T states, obviously opcode fetch machine cycle has 4 T states, so 4 T states only it will require for the complete execution. And the addressing mode, since ADCR, since here the operand is the content of register, or you can say the content of accumulator, and these all are registers, so the addressing mode will be register addressing mode. I'm ending this class here. We'll continue with the instructions set in my next lecture also. Thank you.